Hey guys, welcome back. Today is day 75 and we are going to learn about direct and inverse variation. So direct variation is a specific relationship in where there is a constant of proportionality, it's called. So let's write it's like of proportionality. So think about a proportion. So okay, it reads as y varies directly with x, meaning that when x increases, y increases by the same factor. Okay, so a direct variation is written in the form of y is equal to kx. Okay, in which k is actually equal to, if we solve for k would be equal to y divided by x. All right, so the graph of a direct variation always goes through the origin. All right, that's really important. Okay, so y equals 5x is an example of a direct variation. The constant of proportionality is 5. That's really the slope if you were in slope-intercept form. So let's think of this as y equals mx plus b. Notice your b is 0, which is the origin, and your m is the slope, which is 5. So the constant of proportionality is really the same as the slope. Okay? So if we had the example y equals 5x plus 5, that's not an example of a direct variation because notice the y-intercept here is 5. It's not going to go through the origin. So if we look at the graph for y equals 5x, we go through the origin and we have a slope of 5. So that is an example of a direct variation. So as your inputs increase, your x's increase, your y's increase. Okay? If your inputs decrease, your y's decrease. Okay. An inverse variation is a relationship between two variables in which the product is a constant. It reads as y varies inversely with x, so that when one variable increases, the other decreases in proportion, so that the product, if you took the two of them and multiplied them, it would remain unchanged. So an inverse variation is always written in the form of y is equal to k divided by x, okay, which is the same as k is equal to x times y. All right, so an inverse variation creates a graph that's called a hyperbola. Think hyperbola, but it's hyperbola. Okay, so if we had an example y equals 5 divided by x, this is an example of an inverse variation. The constant of proportionality, that's our k, is 5. All right. Notice y equals x divided by 5 is not an example of an inverse variation. The 5 value, or the constant of proportionality, must be in the numerator. Okay? Now the graph for y equals 5 divided by x makes that hyperbola. All right? Notice you've got values here in the first quadrant and the third. All right? You could also have it in the second and the fourth. Okay, so let's look at some examples. We're just going to see if these represent a direct variation, an inverse variation, or neither, and then find the constant of proportionality. So I can look at number 1 and easily see it's in slope-intercept form, and because my y-intercept is going to be 0, or the origin, I can say this is a direct, and my k is equal to -5. All right. Number 2, all right, this is an example of an inverse. And in this case, my k is equal to 2, my constant of proportionality. Now, with number 3, I need to put it into slope-intercept form. So y is going to be equal to x plus 4. But I notice it's not a direct because we don't have a y-intercept of 0, or it doesn't go through the origin. So this one's going to be neither. All right. If I look at number 4, it is an example of an inverse. And in this case, my k is going to be equal to 9. All right. Number 5, this is actually a direct. And my k is equal to 1/2. All right. If I look at number 6, we're going to actually solve for, so we got u is equal to 1/18. Okay. It's going to be a direct, because even though it looks like it would be inverse, this is really the same as u is equal to 1/18 I. Okay, so that would be a direct, and in that case, our k would be equal to 1 over 18. All right, number 7, if we solve for y, we're going to get y is equal to 1 divided by x. All right, in this example, it is an inverse, and our k is equal to 1. And number 8, this is an example of an inverse, and our k is equal to -2. So right now, you might want to stop the video and try a few on your own. We'll go ahead. Number 9 is going to be neither. We're not in the form. Number 10, we're going to solve for y, and we get -3y equals -3x. We divide both sides by the -3, and we end up with y is equal to, that would just be x. So y is equal to x, and that's going to be a direct. It's a direct, and our k is equal to that coefficient, which is 1. All right, so for number 11, we want to multiply both sides by x to get rid of that fraction. So we end up with 4x is equal to y. So that's going to be the same as y equals 4x, which is a direct, and our k is equal to 4. All right, for number 12, in order to solve this, let's multiply both sides by the y to get rid of that fraction. Whatever we do to one side, we do to the other. So when we do that, 8 is equal to 2xy. And then we're going to divide both sides by 2x. All right, so when we do that, 8 divided by 2 is 4. So this 4 over x is going to be equal to y. So that's going to be an example, or we can write it as y equals 4 divided by x. That would be an inverse with our k equal to 4. Okay. So now let's look at some tables. All right, does each table represent a direct variation? If yes, write the equation. So what I'm going to do is say, well, we know that y is equal to k times x. All right, so what that means is k is actually equal to y divided by x. So if we take y and divide by x for each one of these, let's see, we got 3 divided by 1, we got 3. 6 divided by 2, we have 3. 9 divided by 3, we have 3. And 12 divided by 4, we have 3. So that's going to be a direct variation, and in this case, our k is going to be equal to 3. So we can write this as y equals 3x, and it is, yes, a direct variation. Okay, so you divide your y by your y by your x to get your constant of proportionality. So the next one we try, let's take -1 divided by -3, we get 1/3. And then we take 1 divided by -1 and we get -1. So immediately we can say no, it's not going to be a direct variation. All right, if I look at 15, I take my y, which is 0 divided by 2. And then I have a 1, and I divide by 0 divided by 2 is 0, and 1 divided by 4 is obviously not 0, so this is also a no. And you can also tell here because all right, so we'll just move on to here. So then looking at number 16, let's try the same thing. Our y, which is 5, so we're going to take 5 divided by 10 is 1/2. 4 divided by 8 is 1/2. 3 divided by 6 is 1/2, and 2 divided by 4 is 1/2. So this one is yes, and we can write that as y equals 1/2 x, or we can write it as y is equal to x divided by 2, and that's a direct. Okay, either answer is fine. The coefficient is 1/2. All right, so again, good time to pause the video and try the next few. All right, well, actually probably not a good time because these are going to be inverse variations. So with an inverse variation, okay, our k, if we multiply the two together, we should get our constant of proportionality, meaning because, we'll write it down here, if inverse is y is equal to k divided by x, then our k is equal to x times y. So if we multiply them together, and we always get the same numbers, so 2 times 11 is 22. And then we have 4 times 21, all right, we'll multiply like this. We get 84, so right away we know it's not a no because it's not the same. All right, multiply your x and your y. Here we're going to get -5 times -4, and that's 20. And then we have a -4 times -5. We get 20. Then we get a 1. Whoops. 1 times 20, and we get 20. And then we have 2 times 10, and we also get 20. Whoops, kind of messy there. So this would be yes. And our constant would be a 20, so we can write this as y is equal to 20 divided by x. Okay, all right, so number 19, when we multiply them together, we get 100 and, let's erase this little mess here. All right, so we get 10 times 160 is equal to 1600. And then we have 23 times 368. When we multiply that out, we end up with 8,464. So immediately we can say no because they're not the same. And then number 20, when we multiply them together, all right, I'm just going to multiply right here. We're going to get 18. We get 18, we get 18, and we get 18. So we can say yes on this one, and our y is going to be equal to 18 divided by x. Okay, so our constant of proportionality would be that 18. Okay, so what we're going to do now is look at some examples of some graphs, okay? So if we look at the graphs, all right, it says tell whether the graph represents a direct variation. If so, identify the constant of proportionality. All right, so if we look through this and it actually goes through the origin, we can say that it is. And in this case, the constant is the slope. K is 2. Okay, this one immediately we can see it doesn't go through the origin, so it's a no. Okay, this one it goes through the origin, so it's a yes. And our constant is going to be our slope. We go down 1 and over 1, so that's going to be a -1. Okay, so it's pretty easy to see if it's a direct variation. It just needs to go through the origin, and then you figure out the slope. All right, now an inverse variation, remember, it has to be hyperbola. Okay, so immediately we can look at this and say, no, that's not a hyperbola. Nope, nope, nope. Here we go. Here's a hyperbola. So you're going to have the two curves in the two different quadrants. This one would be no, and this one would be no. All right, so now you can try the next three. All right, if we look at the circle, we're going to say no. This one we're going to say yes. We got a hyperbola, and we have another hyperbola. Okay. All right, so given that y varies inversely with x, all right, that's going to be a key word. Use the specified values to write an inverse variation equation that relates x and y, and then find the value of y when x is equal to 2. Okay, so how we're going to do this, when it says inversely, we're going to think of y is equal to k divided by x, right? Okay, so now we're just going to plug in the values. All right, so it says we know it varies inversely, so we're going to use these two values that we have, 7 and 2, and we're going to plug in the x. Let's see, the x is 7, the y is 2. So 2 is then going to be equal to k divided by 7. All right, so when we do that, we can solve for k just by multiplying both sides by 7, and we get our k is equal to 14. All right, once we have our k, this is important, we then plug it back in to the original inverse proportion equation, and we write our equation. So we're going to find, so we get y now is equal to 14 divided by x. Now we can use that to make a prediction. So this says, okay, find the value of y when x is equal to 2. All right, so now we can find y, if x is 2, we just plug in y is equal to 14 divided by 2, or our y is 7. All right, so our two answers that we have would be the equation and then finding the value. All right, so we're going to try the next one. Again, y equals k divided by x. Put in your two values. Your y is 9, your x is 3. So multiply those two, both sides by 3, and we get our k is equal to 27. Take that 27, make the equation y is equal to 27 divided by x. There's our first answer. All right, now we're predicting the answer when x is equal to 2. So y is equal to 27 halves. Okay, so that's all we do. All right, you can go ahead and we'll go ahead and do the 35, same thing. Y is equal to k divided by x, right? All right, when we do that, now we look at our examples. We've got x is -3, y is 1, so 1 equals k divided by -3. We multiply both sides by -3, and our k is equal to -3. We take that -3, we plug it back into the equation. All right, that's supposed to be an x. K -3 divided by x. And now we make our prediction. So we're finding the value when x is 2. So there's our first answer. Now y is equal to -3/2. There's our second answer. All right, so the next three would probably be really good for you to pause the video and try them yourself. Okay, we'll go ahead and instead of doing them all for purposes of time, I'm going to have you look at the key that's out on student view. Okay, so that we can get to the next example. All right, so the next one says, given that y varies directly with x, okay, so when we do the direct variation, we know that our y is equal to kx. And we're going to do the same thing. We're just going to plug in the values that relate x and y, get the equation, and then predict when x is 3. So if y is equal, so if we have in our first example, our 8 is going to be equal to k times 2. We're going to divide both sides by 2 and get our k is equal to 4. Once we get our k, we plug it back in, y is equal to 4x. That's our first answer. Now we make our prediction. Okay, when x is 3, our y is equal to 4 times 3, and our y would be 12. Okay, so y varies directly with x. We know that y is equal to kx. Our y is -3, and then our x is also -3. We're going to divide both sides by -3 to solve for k. Our k is 1. We take that 1, we plug it back in. Y is equal to 1x, or just x. So there's the first part of our answer. Then we make our prediction. If x is 3, y is going to be also equal to 3. And there's our second answer. Okay, again, y is varying directly with x, so y is equal to kx. Our y is 12, is equal to k times -6. We divide both sides by that -6, and our k is -2. We take it, we plug it back in, y is equal to -2x. And now we make our prediction. So y is equal to -2 times 3. Our y is -6. Okay, so there's our two answers. All right, so again, I want you to pause the video and try 42, 43, and 44 and look at the key on Schoology to make sure that you got them right. All right, bye-bye.